About 8 million years ago, a little baleen whale was swimming in the warm coastal waters of Peru. It was only about 3 or 4 meters long, about the size of a beluga whale, and while it filtered mouthfuls of plankton-rich water, it was unaware that just below it swam a predator. Like the great white sharks of our time, this predator likely hunted whales from below or behind, in case its prey was capable of echolocation. It turns out that this little whale, known as Piscobalaena, didn't have that ability, but for the hunter, the element of surprise was enough. It swam up for the attack, and that was that for Piscobalaena. We know who the predator was because it left a tooth in the whale's body, which eventually fossilized. It usually goes by its species name, Megalodon, and it was the largest shark that ever lived. At up to 18 meters, it was almost 3/4 of the size of a modern blue whale. Its teeth were as big as your hand or bigger, and its jaws were wide enough to swallow you whole. Megalodon lived all over the world, from the Netherlands to New Zealand. And for more than 10 million years, it was at the top of its game as the ocean's apex predator, until 2.6 million years ago when it went extinct. Yes, really. Don't let Hollywood convince you otherwise. I know you're smarter than that. Megalodon disappeared entirely from the fossil record, just as the Pliocene gave way to the Pleistocene. And there's also proof of its extinction in the composition of marine life that we find today, especially in the kinds and sizes of whales that swim in our modern oceans. So what happened to the largest shark in history? Well, it turns out that while Megalodon may have been the biggest shark that ever swam, it would eventually be defeated by the greatest. Megalodon was the biggest, scariest shark in a family of big, scary sharks. It belongs to the diverse order of sharks known as lamniforms, which today includes sand tigers, goblins, threshers, and the great white. And when Megalodon was first described in 1835, scientists thought that its big, serrated, blade-like teeth looked so much like those of the great white that Megalodon was originally placed in the same family. But today, based on features around the base of its massive teeth, most experts think that it was probably in a separate family whose members are all now extinct, called Otodontidae, also known as the mega-toothed sharks. Now, one of the oldest and smallest of the group of megatooths that gave rise to Megalodon was a shark known as Otodus obliquus, which lived in the early Eocene nearly 20 million years before Megalodon appeared on the scene. And some scientists think that Megalodon belonged to this same genus, Otodus, while others assign it to another genus of extinct sharks called Carcharocles. Either way, Megalodon was the largest of all the megatooths, first showing up in the fossil record about 23 million years ago. So how and why did it get so huge? Well, Megalodon's massive size was linked to the size of its prey, and both were shaped by forces much bigger than themselves. These external forces began at the end of the Mesozoic, when plate tectonics caused the uplift of mountains in North America and Asia. The weathering of these growing mountain ranges pumped massive amounts of nutrient-rich sediment into the oceans, increasing the productivity of ecosystems near the shore. And as the algae and plants grew, so did the Megalodon's preferred food group, marine mammals. Marine mammals like whales, dolphins, and seals all have pretty high fat contents, making them a nutritious, high-calorie snack for any predator that can catch them. And as the marine mammals grew over time, so did the sharks. Over the course of about 20 million years, marine mammals and the line of megatooth sharks that led to Megalodon both doubled in size. And Megalodon in particular started to grow too, fast. Fossils of newborn Megalodon found in places like Panama show that they were about 2 to 3 meters long, half the size of a modern great white shark, and about 1.5 times as large as their ancestor Otodus obliquus. And these massive baby sharks grew like weeds. We know this because shark vertebrae show rings of their growth just like tree rings. And these rings show that Megalodon babies grew almost twice as quickly as Otodus obliquus, reaching their maximum length at around 25 years old. So getting bigger over time and then getting bigger faster probably helped Megalodon keep up in the ongoing size race with the marine mammals they hunted. And hunt it most certainly did. Its teeth have been found stuck in the ribs of many unidentified whale species, as well as tiny Piscobalaena, and even a pinniped about the size of a sea lion. So size was a very useful adaptation for the giant sharks. Until it wasn't. Because 2.6 million years ago, Megalodon disappeared. And there are a couple of potential reasons for this. For one thing, 2.6 million years ago marked the beginning of the Pleistocene, when cooler temperatures and long periods of glaciation began to set in, also known as the Ice Ages. This change in temperature could have affected Megalodon directly, or it could have impacted its food source. That's because the change in climate led to a restructuring of how and where whales lived. As the climate shifted, more productive environments with more food began to take shape closer to the poles, so whales started to spend a lot more time there and became more migratory. So maybe the problem for Megalodon was that its prey started moving to where the water was colder, too cold perhaps for Megalodon to follow. For a long time, scientists thought that this might have been what did in the world's biggest shark. But in 2016, a group of researchers led by Dr. Catalina Pimiento decided to test that hypothesis. Specifically, they tested the assumption that Megalodon couldn't live in cold water. Pimiento and her team used a climate forecasting model to recreate ocean temperatures during the Pliocene and Miocene, and compared those temperatures to where Megalodon had lived. They found that while the shark preferred water from about 12 to 27 degrees Celsius, its fossils were still found in places where the water was as cold as 1 degree. So Megalodon probably was okay with colder water, which makes sense because many large sharks today are mesothermic. They can keep their bodies a little warmer than the surrounding water temperature, which helps them stay active even in colder waters. So if changes to the whale's movement and habitats wasn't the problem, then what was? Well, the disappearance of Megalodon seems to coincide with two big important changes in the animal kingdom. The first was the appearance of new predators that Megalodon had to compete with. For example, starting around the middle of the Miocene, we find the giant sperm whale with the epic name of Leviathan melvillei, named for none other than the author of Moby Dick. But unlike the suction-feeding sperm whales of our time, Leviathan had short, powerful jaws, and its teeth were big, strong, and meant for biting into flesh. Also, at 17 meters long, Leviathan wasn't just snacking on squid, it was eating other whales. And it was only one of many species of carnivorous whales in the Middle Miocene. In the Late Miocene, another adversary shows up in the fossil record, the earliest ancestor of the great white shark, Cucarodon habeli. This shark was a direct competitor with Megalodon, as proven by its tooth marks that have been found in fossils of the same whale species that we know Megalodon ate, namely that little Piscobolina. Then a few million years later, in the early Pliocene, the first fossils appear of the modern great white, Cucarodon cucarius. Now, in addition to having to compete with newer, more nimble sharks like these, some of Megalodon's most important prey, namely whales, were on the decline. Toward the end of the Pliocene, the number of whales dramatically decreased from about 60 whale species to about 40. Many of these species were filter feeders and fed on krill and other organisms, which in turn ate microscopic algae called diatoms. And starting around 3 million years ago, the oceans began to experience a serious drop in diatom diversity. It's not 100% clear why this happened, but it might relate to changes in ocean circulation that took place when North and South America finally came together, and water could no longer circulate between the Pacific and the Atlantic. Regardless of the reasons, fewer diatoms meant fewer krill, which in turn meant fewer whales, and with less food, Megalodon had to compete even harder with the smaller and faster great white shark. Being bigger is great if it gives you the advantage of having access to a different food group, but when it no longer does, it means you're just bulkier and require more food to survive. Which is why 2.6 million years ago, the very last of the Megalodon disappeared from the fossil record. And the absence of the Megalodon may have had a big impact on the world's oceans. In the past couple million years, great white sharks and orcas have taken over the roles of apex predator, but these much smaller carnivores couldn't hunt the larger whales that Megalodon was likely able to eat. For instance, we know that modern great whites frequently eat dolphins half their size, so it's possible that an 18-meter Megalodon was eating whales that were as big as 9 meters, much too big for other predators to handle. And after Megalodon went extinct, the size of whales exploded. During the Pleistocene, the waters grew colder, and the new and improved productivity at the poles meant diatoms bounced back. And this newly productive environment, along with the absence of large predators, meant that the whales were able to become twice as big as the biggest whales of the Pliocene. This is why the blue whale, the largest animal our planet has ever seen, appeared in the fossil record only recently, less than 2 million years ago. Without 18-meter sharks swimming around, the oceans could finally host 25-meter whales. So Megalodon and its ancestors had a great run. Over 30 million years, they became larger in order to eat larger marine mammals. But when those mammals started to disappear and when competition with great white sharks and other predators became too fierce, Megalodon didn't make the evolutionary cut. But it's worth noting that the biggest great white sharks of today are about a meter longer than their ancestors were in the Miocene, and they grow a little faster when they're young too, just like Megalodon did. It took nearly 30 million years for the mega-toothed sharks to reach the enormous size of Megalodon, a slow transformation that took place as whales and other marine mammals slowly grew in size. But whales today are already enormous and face very few predators, which leaves the niche of super shark wide open. So it just might be that the great white shark could become the Megalodon of the future, and that giant sharks might patrol our oceans once again. Thanks for joining me today, and a special thanks to our eontologists Jake Hart, John Ivy, John Davidson-Ing, and Steve. If you'd like to join them in supporting this channel, head over to patreon.com/eons and make your pledge for some neat and nerdy benefits. Now, what do you want to learn about? Leave your girl a comment, and don't forget to go to youtube.com/eons and subscribe.